Okay, this is the video lecture for Honest Math 3, Unit 1, Objective 3. So we are going to start with down at the graphing portion, and I'm going to start with question number 3. So question number 3. So for here, what we want to do is we want to graph this exponential. So I know it's an exponential because the variable is up in the power on a restricted domain where I'm only going to graph the section where it is less than or equal to 3. So less than or equal to 3. So I'm going to go ahead and put it in descriptive form. So I'm going to add the 3 to the other side. And then I want to find my start, so alphabetical order. So I'm looking up here at the power, so nothing being added to the x, so that would be 0. And then opposite here, so that would be -3, so at 0, -3. So that start point that I just found is just for the asymptote, right? So 0, -3. So over 0 and then down 3. So I'm going to use an open dot and then draw a dotted horizontal line because that would be, there is an asymptote for this exponential passing through y equals -3. And then the other thing I like to do is I look to see, what section I'm graphing on. So I'm looking at this part right here, and I want to use a closed dot at 3. So I'm going to just emphasize that by making a little dot there. And I only want to graph when the values of x are smaller than 3. So I'm going to just mark it on my graph here. So I'm going to go over to 3. Just put a 3 there. And then I want to graph only the section smaller than 3. So that means I'm only going to graph if it goes to the left. So I want to go ahead and do a t-table because I'm graphing an exponential. And I'm going to start with the 0. And then I'm going to do, because it's a growth, so the base is greater than 1, so I want to, look to see what's happening to the right, because that will give me a whole number of values if I do that. So I'm going to substitute in 1 as well. So I'm going to go to the original equation, and I'm going to replace the value of x with 0. So I will have 2 to the 0 minus 3. So 2 to the 0 is 1. And then 1 minus 3 is -2. So the ordered pair I'm graphing is 0, -2. So over 0, down 2. Then I want to do the same thing again, and I want to evaluate the function at x equals 1. So it would be 2 to the first, and then -3. So that would be 2 minus 3, which is -1. So the ordered pair I'm graphing is when x is 1, y is -1. So I'm also going to have to figure out what's happening at 3 as well, right? So I need to know what's happening at 3 because that's part of my restricted domain. So I can't just like graph it and just randomly stop it at 3. I need to know where at x equals 3. So I'm going to evaluate the function one more time, but for this time I'm going to choose 3. And so replace x with 3. So 2 to the third is 8, so 2 times 2 times 2. And then 8 minus 3, which is 5. So then my ordered pair is when x is 3, y is equal to 5. And it's a closed dot there. So normally I would just graph and I would draw arrows at both ends, but in this case we're only going to 3. So then when I graph my exponential, I'm going to not draw an arrow at the x equals 3, but I will for less than 3. So then I also want to do my domain and range. So for the domains, I'm just going to do that up here. And I want to do that in interval notation. So domain is how far left, how far right. So this graph goes forever to the left, so that would be -infinity. And then it stops at x equals 3, and then equals 3, so I would have a bracket there. And then for my range, I look to see how low the graph goes, and it can't go below the asymptote. So it goes up to the value of -3, which is the asymptote, but does not equal it. So I would put an open, or parentheses, because it is exclusive, right? So it goes down to -3, but not equal. And then we look to see how high did the graph go, and the highest point is right here, and that was at 5. So then I would say comma 5, and I would square that off because it is a closed dot, because it is equal. So then the range is from -3 to 5. Okay. All right, so let's take a look at question number 4. So for number 4, we're still doing restricted domains, but this time we're putting together two functions that we need to graph. So here I have a top and a bottom function, and both of those together make up f of x. So when I find the domain in the range, and I'm looking at this whole thing, I'm looking to see overall, what is the domain? Overall, what is the range? So I'm going to just look at just that top equation first. So I'm going to just take just that top equation. So I have an exponential. So for me to graph that exponential, I'm going to find my asymptote where it starts. So that would be at -1 and 0. So -1, 0. So there is a start at -1, 0, which is our asymptote. And then I want to do a t-table. And when I do the t-table, so I want to graph all the values for x greater than or equal to -1. So that means the exponential, I'm only going to head off to the right. So when I do that t-table, I want to make sure that I pick numbers to the right of -1. So always start with -1 because that gives you a nice number to work with, and then we're going to go one bigger than that, so I'm also going to plug in or substitute in 0. So again, x is greater than or equal to -1 for the exponential, so when I choose numbers, I want to choose numbers to the right of -1 and also at -1. So then evaluate your function. So replace x with -1, so that would be 0, -1 plus 1. And 3 to the 0 power is 1. So when x is -1, my y value is 1. And we're going to evaluate at 0 as well. And 3 to the first is 3. So I have a closed dot at -1 because of that underline, right? So that closed dot at -1 because of the underline. And then we're headed to the right. So I'm going to draw an arrow at the end of that and kind of curve it so it looks exponential. And then now we're going to do that bottom function as well. So I have that top function that I just got done graphing, and now I want to do the bottom function. So I'm going to put this in descriptive form when I do that, so I'm going to subtract that 3 to the other side. And so I want to find my start. So I'm looking here at x and y, and so I'm going to use -2, +3. And then I have an absolute value graph because of the absolute value, so it's going to be a V shape, and then because my stretch is negative, it's going to go down. And then here, I'm going to go to -1 as well, so for x less than -1. I didn't have enough room to write that here, but so for x less than -1, so that means when I go to graph, I'm going to graph going towards the right, so anything to the right of -1. So here my stretch or my slope is -2. So I would go down 2 over 1, and there's already a dot there, so I don't need to do anything about that. So I don't need to like try to make it an open dot somehow because it doesn't have the underline here. That dot already exists as part of my graph, so I don't need to do anything with that. Like I don't need to circle it to say, oh, it's an open dot because it's not equal, because it's already a closed dot from the first graph. And then I'm going to do the same thing. I'm going to go down 2, but to the left 1. And so then I'm going to connect that for that V shape. So I have kind of this blue color graph came from my linear exponential, or excuse me, linear absolute value, and then the purple graph came from my exponential. All right, and then let's go ahead and do domain and range. So domain is how far left to how far right. So this graph goes forever to the left. So that's because of this down arrow here. So forever left. So that would be to negative infinity. And then there's no open dots on the graph itself. There's the open dot for the asymptote boundary, but that's just to give a guideline for the exponential. So then over here, it goes forever up and to the right. So that would be positive infinity. Or our real numbers, right? And then for the range, goes down forever because of that. And then there's no break in the graph, and then it goes up forever. So negative infinity to infinity. Okay. Okay, so we're going to take a look at one more graph here. We're going to do number 6. So this time I have 3 pieces that I have to put together. So we'll start with the top equation. So that is y is equal to 5, and that's for if x is less than negative 3. So I'm going to go to where y is equal to 5. And then normally we would draw just a horizontal line that goes through y equals 5. So, but here I have to pay attention to the fact that I'm only going to do that for when x is less than negative 3. So I always want to mark here on the x so I can see that clearly. So there's negative 3. And so less than negative 3, that means we're going to go that way. And it's an open dot. So at negative 3, 5, I'm going to put an open dot, and then I'm going to draw a horizontal line to the left. So y is equal to 5. That's this line right here, but only for the values of x less than negative 3. So open dot because it's not underlined, and that's the top graph. And then let's go ahead and do the middle. So this is a linear graph, so I move the 1 to the other side. So my start, it will be at 0, because nothing being added or subtracted to the x, and then comma 1. So over 0, up 1. And then my slope or my stretch is 2. So this is just a straight line. So now again, I'm going to pay attention. So at negative 3, I'm going to have a closed dot. And I'm also going to have a closed dot at 1 because these are both underlined. And then I'm going to mark the 1 over here so I can see where I stop. So my slope is 2. So from here I'm going to go up 2 over 1, and I'm using a closed dot. And then I don't keep going because I want to stop when I get to 1. I want to stop when I get to x equals 1. And then now I'm going to go the other way. So down to left 1. And keep going, and I'm going to stop once I get to negative 3. And again, close dots. And then I have one more graph to do, the bottom one. So I'm just going to look up here because I'm kind of in a corner there. So these are both going to be open dots, and I'm only going from 1 to 2. So I'm doing just the tiniest little sliver of that graph. So because it's such a tiny part, instead of going into detail about start and all of that, I'm just going to evaluate that equation at 1 and 2, because it will be just the tiniest little bit of the graph between 1 and 2. Like, I'm not going to go into detail on start and all that, because I only have to graph really just 2 points and connect them. So I'll evaluate this bottom equation at 1. So that's just 1/2 minus 2, which is -1.5. And again, it's open dot for both of those. Let me zoom in just a bit and try to keep on the graph and the t-table at the same time. There we go. And then evaluate at 2. So 1/2 squared is 1/4, and 1/4 minus 2 is -1 3/4. I really, that's kind of tight there. Okay, so there is the graph for 1/2 x minus 2. And then I'm just going to kind of connect that. Super hard to see, but that would be my graph. Just that little tiny, tiny, tiny piece. Okay. So now for domain and range. So I have a split. Do I have a split domain? No, I don't. That's good. Okay, so for my domain, so it goes forever left because of that arrow. And then even though it stops here at -3, there's also a closed dot at -3. So then that's part of my domain. And then a closed dot here. So even though there's an open dot, there's a closed dot here. And then it goes, and furthest it goes up to is 2. And it's an open dot, so parentheses. So at 2, there's an open dot. And then for the range, so the lowest the graph goes is to here. So down to -5 and equaling because it's a closed. And then goes up until we get to this closed dot, which is at 3. And then it jumps to 5. Oops, I just saw the open dot, so I started to do parentheses, but it's closed over here, so that should be a bracket there. Okay, and there's my domain and range. Okay, so let's go ahead and take a look at this graph here. So for this one, so for part A, so they just want us to do the domain and the range here for f of x. So let's go ahead and do that. And I think is that a closed dot? Yeah. Okay, so all right, and I'll just do that up here. So domain and range. So it's a closed dot at -5. So that's how far left it goes. And it goes far right to 3, so closed on the 3 as well. So the domain is from -5 to 3. So let me write that just a little bigger. The range, the lowest it goes is right here, so that would be at -4. And the highest is 0. So it doesn't go below -4 and doesn't go above 0. So there's part A. And then for part B, they want us to graph the domain, or graph g of x, and then state the domain and range. So we're going to graph g of x. So I'm going to put it in descriptive form. So I'm just going to do that down below here. So I'm going to move the 4 over, and then all right, so we're doing a transformation. So for this transformation, so that means then that I'm going to go right 3, and down 4. So right 3, down 4. And by, I just saw that. How about, so right 3 and up 4. Sorry. I'm like, wait, that's all right. Okay, so I want to go right 3 and up 4. So I am just going to kind of move just a couple of dots just to give us the idea of how to do that. So I'm just going to start here, and I'm going to move this line right 3 and up 4. And then I'm going to move this one the same, so right 3 and up 4. So this whole line I moved right 3 up 4. And then I have this like little curve here, so this dot is that dot up here. So I'm just going to move this one, so right 3 and up 4. And then put that curve. That's not a very good curve. So that is mimicking this one. And then now I'm going to go ahead, and then I'm just going to kind of copy. So this, and then I'm just going to copy this diagonal from the tip of here. So I'm just going to make that little diagonal from the tip, and then make that little diagonal from the tip. And then label that G. So for when I go to do the domain, I would just go left to right, top to bottom. So I'm not going to do that one, but I do want to make sure that I spend some time on these two here. So here, we don't have to graph it, we just have to say what the transformation is. So here, this transformation, so the y values are opposite, right? So this is the same as negative y. So if the y values are opposite, anything that was a positive y will turn to a negative y, or anything negative will turn to positive. So then this would be a reflection across the x-axis. And then this one right here, so this is a negative x, so that means the x's are opposite. So if the x's are opposite, if it was negative, it'll turn positive, and anything positive will turn negative. So it's going back and forth this way, so it's going across the y-axis. So now for the domain, what we want to take a look at is we need to kind of pay attention so we don't have to like redraw everything, just kind of think about what's happening. So let's go ahead and do the domain and range for both of these. So for here, this was my original domain up here, right? There's my original domain and my original range. So if I'm reflecting across the x-axis, so anything that was here is coming down here. So I'm only changing the y values, so the domain is not changing. So I'm only looking at this graph right here, right? This is my f of x graph. So my domain doesn't change because negative 5, right, at x equals negative 5, when this was y equals negative 3, it's going to jump up to positive 3. But the x didn't change. So my domain is going to still be exactly the same, negative 5 to 3. Like that's not going to change at all. And then now what about my range? So the range will change and it will become opposite, right? Because that's what I'm doing, opposite y values. So instead of the lowest point being negative 4, it's going to reflect and that will become my highest point. So negative 4 will switch to positive 4 and become my highest point. And then now my lowest point will still be 0 because I can't do opposite of 0. That will be 0. All right, and then let's take a look at this one here. So again, so we're doing reflection across the y-axis, so my x's are opposite. So we're going to take a look at the range. So this graph here, so the x's become opposite. So instead of 3, it goes to negative 3. Instead of negative 5, it goes to positive 5. So when I'm doing that, my y values don't change at all, so my range will be exactly the same. And then my domain is what will become opposite. So instead of going far right 3, it will now go far left negative 3. And then negative 5 will jump over to positive 5. And that would be my domain and range. And that's it.